Good afternoon and good morning to those of you out west. Welcome to today's webinar from Metal Architecture Magazine and AEP SPAN. My name is Stacy Ranella and I'm the Editor-in-Chief for Metal Architecture, and I'll be moderating today's presentation. Just to cover a few housekeeping items before we get started, it may take up to 5 business days if you're requiring a certificate, so keep an eye out on your inbox and don't forget to check your spam or junk folder. If you have any questions during today's webinar, please enter them using the Q&A section, which you can find at the bottom of your Zoom window. We will address as many questions as possible during and at the end of the presentation. Zoom does have a raise hand function, but since we'll be keeping everyone's mics muted, only use the Q&A instead. If you are experiencing any technical difficulties during the webinar, you can enter a message in the chat, which you'll find right next to the Q&A, and we'll do our best to help. Today's webinar is being recorded and will be available on Metal Architecture's website by this time next week. Now I'd like to introduce our speaker, Jeffrey Medeiros. Jeff is the architectural representative for AEP SPAN and is a licensed contractor who has been supporting architects in California for more than 20 years. Jeff can spec write, assist in detailed drawing, and aid in production selection or any aspect of the design build process from initial design to complete bid-ready documents. He's fluent in building code, bid laws, and contract code. He provides architects with a full range of services from conception through bid. He holds various degrees, including law and society from UC Santa Barbara, Japanese from Waseda University in Tokyo, and he attended McGeorge School of Law in Sacramento. He's fluent in all types of roofing systems, built up and torch applied, hot and cold process restoration coatings such as silicone, urethanes, and acrylics, single ply roofing, and all forms of metal applications, including roof-to-wall coping and soffit, as well as flashing trim. Jeff made the move to AEP SPAN over 6 years ago after spending years with a competitor and plans to stay on through retirement. In this webinar, Jeff will discuss single skin metal siding, performance, and installation considerations. Jeff, we appreciate you joining us today. Please take it away.
Hey everyone, good morning or good afternoon. Do want to preface this by letting you know there's some neighbor has some work going on outside. So if you hear mobile equipment, that's what's going on, all right? Okay. I like to run these as more of a choose your own adventure. We're gonna go off, and we may go off the rails a little bit, but we're gonna make it through this. I may skip some, but we'll stop if you have any questions or concerns. So let's jump in. So AIA certs will be taken care of automatically. This is the slideshow that we have to, the one slide that I have to show for the learning unit. All right, moving on. Course description. This is going to be the only slide that I'm going to read. Single skin metal wall siding is a great example of the continued advancement of building products in the architectural market that's driven by more sophisticated designs and greater emphasis on sustainable building practices. All right, that's enough of that. Topics that we're going to discuss include material inputs, performance attributes, environmental impact, sustainability, and installation considerations, detailing the differences between through fastened and exposed fastener panels. Okay, so at the end of this course, there we go. Learning objective 1, let's jump in. Let's talk about materials in paint. Okay, so let's start at the base of a metal panel, that base steel / aluminum component, right? So that comes in as bare steel, right? Or bare aluminum. And the base of the metal panel is choose your own metal, right? Steel panels are offered in a range of thicknesses, 18 through 29 gauge. Your typical architectural sizes are going to be 20, 22, and 24. Industrial applications are going to be your lighter gauges, 26 through 29. The aluminum standard is 050, 040, and 032. They do not correlate directly with the steel gauge thicknesses. One thing I do want to point out on this slide is it's 100% recyclable. Surprise, bet you didn't know that. Okay, moving on. Coating system. The metal comes in, right? And the first thing that happens is it goes through an aluminum zinc coating or a galvanized coating, but typically it's an aluminum zinc coating. This is Galvalume Zincalume, okay? Tissues, Kleenex. Toilet paper, Charmin. Same thing. Okay, zinc aluminum galvanum. That's the 55-45 aluminum to zinc. The aluminum component, the 55%, is that barrier protection in its inner, doesn't react, right? Doesn't corrode. The zinc component provides that sacrificial characteristic. This is typically applied on your architectural finishes, your architectural thicknesses, excuse me. So 22, 24, 26, 29-ish. Galvanized coating is different. That is your 100% zinc coating. That's what comes in your G60s or your G90s, G90 being the thicker coating, of course. Okay, key takeaway here. Typically, and what I mean by typically, I mean almost always, like 99.9% of instances, there is no substrate warranty offered. Dang, bells are going off on your head, right? No substrate warranty with galvanized coatings. That means if you have a manufacturer that's supplying a G60 panel with Kynar paint, there is a paint warranty, but no substrate. So the better choice in this situation is Galvalume zinc aluminum. Of course, aluminum panels don't require this coating because aluminum is naturally develops that oxide film on the surface, right? So aluminum doesn't go through that. Okay, so the primer coat goes on. Let's build this up. So you have your base steel, then your aluminum zinc coating, your Galvalume zinc aluminum. Then your primer coat for the top paint adhesion layer. Now this is the Kynar color. You know, pick whatever color that you want. The bottom layer, though, the bottom layer isn't Kynar. It's expensive to do Kynar paint, right? So the bottom layer is just a backer coat. It's an inexpensive polyester paint, okay? Really to protect the panel when it's being handled. So again, maybe bells are going off. If you want your panel with colors on both sides, i.e. canopy, right? And you want to be able to look up and see the blue over your open purlin or open framing, and up top it's blue as well. It has to be coated on both sides. There is order minimums associated with that. Typically speaking, it is 1,500 foot of mother width coil. And what do I mean by mother width coil? We're going to go back to another toilet paper analogy here. Excuse me, this is twice in one sitting. Imagine a roll of toilet paper. Now turn it eye to the sky, so it's facing up. Now make it metal. Now make it this big around. That's a coil of metal, okay? So 1,500 lineal foot of that coil is the minimum amount that we can feed through rollers and up and down into tanks and through this and back through that and dryers and colors and all this to get that color on. So that's going to equate to about 3,500 square feet. Okay. Moving on. So what's this one about? Oh, zinc aluminum. Okay. So you don't have to have a paint just because you let's say you want it to look more metallically. Imagine the old like McDonnell Douglas DC, what, 3s and 7s airplanes, or what's the current airline? American Airlines, I think. It's kind of silvery. That look, that's your Galvalume zinc aluminum finish. That just has the finish on it. Now, that would be your quote unquote substrate warranty. There's no paint warranty with that. But Galvalume zinc aluminum is so awesome. You get a 25-year finish warranty on that with an exposed substrate. So you can also paint it. So if you want to do custom color and you don't want to pay for the minimum order run, you can paint this as well. So that's your other option. It's typically less expensive because there's no paint on it. All right, there's 3 paint systems: good, better, best. I love this, right? Ooh, polyester, that's your backer coat. Okay, that's what we use on architectural metal, the thicker gauges, as a backer coat. You can also get it on panels. I'm going to go off the rails here real quick. This is exactly why in your specifications, every single one of you, there's 213 people on right now. Every single one of you, 213 people, are always going to specify the following: all sheet metal, flashing and trim shall be sourced from the same manufacturer as who provides the metal panel in order to, number one, maintain an exact paint system, right? And number two, a congruent warranty. So once again, an exact paint system. If you don't do that, your contractors can go out and they can buy panels that are Kynar finished, and then they can go to your local ABC, RSG, Diamond roofing supply house, and they can get their white or their regal white or their regal blue and whatever color that's a polyester paint system. Oh, it's cheaper there. Well, yeah, no duh, right? It's a cheaper paint system, and you're going to make flashing and trim out of that, and it's going to yellow out in 5 years, and your panels are going to look great, and your trim's going to be yellow, right? So not all paint systems are equivalent. Anyway, back on track now. So polyester is what we use as the backer coat. SMP paint system, silicon modified polyesters, right? Offers a better resistance to color, chalk and fade, very versatile paint systems. You will typically see this as your paint system when you purchase from a roofing supply house, okay? This is better than polyesters, less expensive as compared to PVDFs, Kynars, has a longer film integrity, longer chalk and fade, but it's used on lighter gauge metals. And what I mean by this is, picture a piece of standard paper, right? It's going to flex, it's going to move, right? That is your 26, 29 gauge metals, right? They move, they're more flexible, they're thinner. Now picture a piece of cardstock. It's not going to move as much. It'll still move, but not as much, right? That's your thicker gauge, 24, 22, 20. Now, the reason that I give you this differentiation here is because SMPs can move with the metal. Kynars aren't as good at that. Kynars may crack and craze on lighter gauge metals. So typically speaking, all your lighter gauge metals are going to be SMP paint systems. Here is your Cadillac, or, you know, choose your car of choice that you want, right? This is your top of the line PVDF, right? Okay, used on much more high-end architectural projects on 22, 24, and 20 gauge products. This paint can be referred to as Kynar, Kynar 500, Hylar 5000, Duratec 5000, all the same thing, okay? All the exact same thing. It comes in a wide range of colors, whatever color you want. Actually, we can do neon pink if you'd like. Thing is this is the longest film integrity chalk and fade warranty. This is your paint finish warranty that you can specify at 20, 25, 30, and yes, even 40. You heard me, right? First time, even 40 years. That's awesome. Okay. You may not be able to have all the competitors hit that, but we can go out to 40 years now on a Kynar finish. So this is used on more high-end products. All right. The next step up is the PVDF marine systems. And what I mean by this is, if you look in this picture, just because there's ocean in the background doesn't mean you should use aluminum. If you think back to your materials classes, I'm going to go off the rails here again real quick. Aluminum in sheet form and steel in sheet form, okay? Not extruded, enrolled, that toilet paper, eye to the sky coil form, okay? Aluminum doesn't have as good as impact resistance as steel. Think of your grandfather's car. A shopping cart hits it. Oh, that's not a big deal. I'll go home, take off the door panel, hammer it out. It's fine. Do that to an aluminum door or modern, you know, composite door. You're like, dude, you're buying a new door panel, okay? Steel has memory. Aluminum does not. Because of this, steel has a higher impact resistance than aluminum. Steel has higher performance characteristics than aluminum. You may need 2 times the fasteners to hold a roof down or a wall down with aluminum as compared to steel. Anyway, what I'm saying here is, just because you're on the ocean doesn't mean you need to go with aluminum. You can go with steel, and there's steel coatings that are marine paint systems that you can put on a boathouse. like directly over the water, 15-year warranty, 20-year warranty. The marine paint systems can all use the same colors. They're over the aluminum zinc, galvanum zinc loom substrate with the substrate warranty. So keep your mind open on that. All right. This one has way too many words, and I'm going to make it real simple. Don't pay attention to this slide, okay? What I want you to think about when you see cool. Okay, are you ready? Imagine Tinkerbell. Yes, Tinkerbell, the Disney fairy. And she reaches into her little bag and she pulls out these sprinkles and she sprinkles them on and she puts fairy dust into the paint. That is what cool means, okay? It is a IR pigment that is someone way smarter than me came up with to literally sprinkle into the paint. So when the paint is coated on the steel, it drops the overall SRI. It is magic fairy dust. Cool is magic fairy dust. It does not change the color. It doesn't change anything but the performance, and it drops it by a couple of points. That is what cool means. So cool red, or let's give it a specific name, cool colonial red, which is common, is the exact same as colonial red, but cool colonial red, same color, will have the magic fairy dust in it, and it drops the overall SRI. Okay. LRV, this is the amount of visible or usable light that reflects from a surface. This is, say that you're in Vegas. There was this big thing in Vegas where they put up this new metal wall, and or glazing, for example, like in this photo, right? But the light hits it and it reflects down, and people on a rooftop pool are getting sunburned. Well, that's LRV. So pay attention to that. We can dive into that later. It's expressed as a percentage 0 to 100, but there's more specific things in here because it takes into consideration gloss and sheen and all this. So that's what that means: visible or usable light that reflects from the surface. Okay. Before I take questions on this, there is one thing that I wanted to talk about, and I'm going to go off real quick. The EV industry, and this is you've heard it here first. Okay, the EV industry has may substantially impact the paint systems that are going to come up. And what I mean by this is, and there's a negative side and a positive side in EVs, right? In your battery. The separator there is the PVDF resin. That's what's used in Kynar. As I'm sure you know, Elon Musk at Tesla and Ford and Toyota have a much larger pull than the paint manufacturers. So they are getting that resin first. If it's going to ramp up the way that it's supposed to ramp up, that resin may, I'm not saying it is, but it may become expensive or harder to obtain to the point where the PVDF Kynar colors may become impacted because the price will jump up or the resin availability won't be there. So tuck that away in the back of your mind. May happen down the road, but I did want to bring it to your attention. All right, questions?
Okay, thank you, Jeff. First question. How do you control the batch-to-batch color consistency? Is color consistency better with an SMP or PVDF paint system?
That is a super good question. Gold star to whoever asked that. Batch sensitivity is a real thing. So for standardized colors, batch sensitivity is virtually eliminated. And what I mean by this is, if you've ever painted the interior of your home and you go to like Home Depot or Lowe's and you watch them mix the paint and this machine comes out and it puts the exact amount into that base white color and then it mixes it, that's how standard colors work, but on an industrial scale with, to be honest with you, much more precise measurements due to batch size. Where batch sensitivity does come in, and it will come in big time, okay, is on your metallics, on your prints, and on your specialty finishes. So when you're ordering those, everything that you want, you don't do those projects. Like if you have, don't stagger them out. What am I looking for? There's a term, and I'm just going blank. Don't do one project and then a year later do another one, right? Oh my gosh, I'm going to come to me after this. Anyway, You want all that material ordered at one point. Even if you don't use it, order all the coil, have it all, so it's all from the same batch and there's no batch sensitivity. So that rust colored, in the photo, that rust colored screen that you see there will have batch sensitivity because it's more of a print. So very good question. As far as SMP versus Kynar, no, it's going to be the same across the board. It's really due to colors, print differences, metallics, and so on.
Okay, next question. Is the backer coat always a polyester paint system? Will the backer coat have the same or similar lifespan?
The backer coat, okay, again, very good question. Gold star to you as well. The backer coat is typically polyester. It's the cheapest, easiest paint to put on. In some cases, it will be SMP, but it is never going to be Kynar because it is very much more expensive. The backer coat, I would venture to say almost overwhelmingly is always polyester. Now, the color can vary because that's not a batch sensitive, not a maintained color. So it could be white, off-white, a variation of that white. So, but it's going to be one of those. And no, it has nowhere near the same lifespan as Kynar. Kynar is exposed all day, every day, right? 30, 40-year warranty, good to go. Polyester, no. It is typically shielded from UV and it's underneath, buried in the roof, so it's not even viewed, or buried in a wall, so it's not seen. The only instances where it's exposed is in canopy type applications and so on. And it's okay to leave it open there, but it will not have the same lifespan as Kynar.
Okay, let's get back to the presentation and we will address some more questions in a little bit.
All righty, learning objective 2, environmental impact. I'm going to skip through this one quickly because there's other stuff I want to get onto, and we've already been doing this for 22 minutes. So I already talked to you about what COOL is. High level overview of this is, what is it? The California Energy Commission's evaluated this, and they said in climate zones 1 through 4, they used the program to model energy consumption for project types, multifamily, office buildings, hotels, etc. And the findings from the research indicate that COOL siting, again, COOL, magic fairy dust siting, saves energy, money, and carbon dioxide in warm climates, mitigates urban heat islands, and they tend to stay cleaner. Big surprise, right? Okay. So COOL sightings, all the colors are cool. Now, it's cool colonial red, cool regal white, all that. So we're going to skip through this pretty quickly. LEED, living building, green glow, all of that. This is a rabbit hole we could spend an entire 2-hour presentation on. I'm going to let you all know if you have specific questions in regards to what will get you certain points on what with what color, contact me after. Like, it's way too in depth. Okay. From a green building certification standpoint, we have conducted a comprehensive assessment of LEED to determine how metal roof and siding products could contribute. What I will say is that depending on the design of your project, metal siding panels can contribute to green design and certification programs. Again, rabbit hole that we don't want to go down right now. Contact me outside of this. For the living building challenge, this is much more nuanced. Okay. Building products do fit into the materials pedal red list, but to be eligible, okay, this is craziness. A manufacturer has to disclose 100% of their ingredients to a 100 parts per million. Okay, materials, chemicals that are on the red list. We don't manufacture the paint. There's really 2 or 3 really big players in the paint. They don't want to give up their formula. So until the paint manufacturers that we coat our products with are willing to give up their magic formula, which is, heck man, I don't think it's ever going to happen. But The paint systems is what's causing the issue with this. So you can do a zinc aluminum galvalume coating and you can hit and get through on the materials pedal on the red list under LBC. The painted ones are the issue, and it's not because of us. Again, it's because of the paint manufacturers. So, oh, I just went through this. Forgot that this was the next slide. So they can be ordered. You can get it in multiple profiles. Metal siding with galvalume zinc aluminum does meet LBC red list free criteria. This is the only one if you're going that route. Okay. So I touched on this as well. There's drastic hesitation by the coating manufacturers to give that proprietary information. So the industry's been working through this, and there's been some performance trade-offs, which until recently was pretty significant. So this is an ongoing process that we're actively pursuing and trying to figure out how to get painted panels through. But it's 100% disclosure. So probably no questions on that. We can stop briefly if there is. No, all right, I'm moving on. Okay, wait, I'll wait for you. Sorry.
Sorry, 1 second, Jeff. Okay, we do have a few more questions coming in. Can you attach single skin panels directly to framing, or is a substrate always needed?
No, they can go straight to framing.
Is the paint warranty different if the shapes have a lot of tight 90-degree folds?
No. So, interesting question. I've never been asked that before. Okay, so imagine that you are a person that has a magic iron, and if you take this corrugated panel off the wall and put it down, you're going to run this magic iron across this panel and you're going to make it go flat. That's the stretch out, okay? That is what the mother width from the mother coil was trimmed to be to roll form the overall profile. So if you have corrugations, it's 32 inches wide, it may need to be 48 3/4, right? So that's the stretch out. It's painted before it's run through the roll form. And if it's boxes or 90s or corrugation or whatever, doesn't matter. When it's run through the roll former, it's already painted. So there's no impact on that warranty, regardless of profile.
Okay, let's do one more. Is there a rule of thumb for recommended panel gauges relative to panel width to avoid oil canning?
Rabbit hole. Let's do it. All right. Okay. Couple things here. Yes, there is. So there's two different types of oil canning. Okay. Oil canning is defined in SMACNA as a measurable, repeatable process of the roll former. That's the one where you look at it as it comes out of the roll former and you're like, every 12 inches, there's a blip. That's oil canning. There's the popular term, popular nomenclature, that's oil canning when you walk up to a building and you look at it and you can put your hands in your hips and you go, I don't like the way that looks because it's wrinkly, okay? That can be impacted on anything. I'm talking temperature fluctuation, gauge, profile, color, handling, shipment, crating, production, whatever can come into this and can impact the overall waviness, right? Like, was it pulled up onto the roof and did it go over the corner and put a hairline little thing you wouldn't see unless you had a microscope out where it's going to flex? Is there a pop rivet in the wrong place that doesn't allow it to move? So that type of oil canning, yes, be thicker. There's things that can be done to mitigate this. It cannot be eliminated completely. Every manufacturer out there will have this in their literature. Oil canning is an inherent part of the metal manufacturing and roll forming process. Steps are taken to eliminate, but it cannot be eliminated completely, and seeing it is not a cause for rejection. Something similar. Colors, choice. Certain colors you can see more than other colors. Thickness is huge, okay? 26, imagine that paper one that I was talking about, the standard piece of paper versus cardstock, it'll ripple more depending on what gauge you go with. Profile, massive, okay? The more predefined points of flexation you have, the better. And what I mean by this is if you take that sheet of paper and you lay it flat on a desk and you put your hands at different points and you push together, the paper's going to flex at a different point every single time. Now, fold that paper down the middle, lay it flat. No matter where you put your fingers along that, it will always flex at the same point you defined, okay? That is what a profile does in metal. And I'll dive into that soon when I talk about exposed versus concealed. But very good question. Everything comes into play. So if you want to mitigate it, thickness, color, profile, grade A install team that's not going to handle it funny or put pop rivets in different places. So there's a lot to take into consideration there.
Okay, we will take a few more questions in a little bit. And for now, we'll get back to the presentation, Jeff.
Okay. 2 types of siding, 2 types of roofing, 2 types of metal, exposed, concealed, right? Exposed. Surprise, surprise, it relies on exposed fasteners to secure the material to the structure. It's like, okay, concealed fasteners, no visible attachment points. Exposed fasteners, by definition, are exposed fasteners, rely on laps and sealant for waterproofing on roofs, on walls, and are corrugated. I don't care what kind of corrugation you have. Sine wave, box rib, trapezoidal, diamond, they're corrugated. And because they're corrugated, you can nest them. They're shipped on pallets. You get 10-foot long panels, boom, nest them, alternate, and it's shipped easy. Concealed fasteners are the complete mirror image of that. No concealed fasteners do not rely on laps and sealant, and they are not nestable. You can't fit a 12-inch or 16-inch wide standing seam like is shown in this photo inside of another 12 or 16-inch standing seam without swedging it. But that's a different discussion. They don't fit. So you have to ship one like this and rotate the other on top and flip it and ship it. So these are more difficult. Generally speaking, exposed fastener is more industrial looking. Concealed fastener is much more architecturally pleasing. Okay. So what I just touched on here is the lapping. As you can see, whether it's on siding or put it on a roof, they rely on laps and sealant. These can be any gauge really, but it's 29 typically through 22. A question that should be going through all of your heads now is, you talked about pinning a panel earlier, Jeff. These fasteners go through the panels. Doesn't that pin them? Yes. Yes, to all 237 of you. That is a very good observation. Yes, it will. It will pin the panel. It will thermally lock the panel. So, Jeff, how do these panels move? Fantastic question, team, collective team. Every single one of those repeated conditions, profiles, act as a little spring. Okay, the movement gets absorbed there. Now, over time, it will make a hole where the fasteners go through, especially if it's exposed to drastic temperature changes. Okay, think of like a nail backing out on your fence when you walk by to take the trash out. You're like, whoa, almost hit that thing. That nail, similar to this, not the exact same, but similar to this, because the wood's swelling and expanding and contracting, and that nail's heating up and cooling off, it'll back out. This will happen with these fasteners as well. So you may have to check them. The fix is you remove the number 10 and put a number 12 in, and they have a gasketed washer. So, not a huge deal, but if you're on a roof after 20 years and you have to check 2,000 to 5,000 fasteners, it could kind of be a pain. Something to take into consideration when you're specifying this, but that's how they'll move, is those little repetitions in corrugations act as springs, okay? Doesn't matter what profile. They're all through fastened They all rely on laps and sealant, and they're all nestable. Okay, exposed fastener profiles. Looks good, right? You can use them. They're more industrial looking. You know, you can use them from anything from equestrian centers, parks and recs, you know, wine cellars. If you're an interior designer, looks awesome, right? So, exposed fastener profiles. You know those three. Okay, concealed fastener profiles. This is the antithesis to that, right? Everything's different. These are typically only in the 24 and 22 gauge range. They're almost always 12-inch modules. So if you take these panels that are shown on the bottom here, the black to tan to silver to blue, those are different profiles within the same panel range. They all interlock. You can mix and match them. You can do different colors. You can do one, you know, bright silver across a matte black. It would look amazing. And you can do a bunch of different things with these panels that you can't do with concealed. This is the mix and match. This is the higher end architectural, super good looking, thicker material, more expensive, okay? More expensive to install as well because it takes more nuance. But this is the type of panel that you can do anything under the sun with, okay? Concealed profile, concealed clip holds it in place, allows the panel to move. No visible attachment points. All right. So this one here, if you can see my mouse cursor moving, that's green, is Oceanside Performing Arts Center. If you look closely at that one, I'm going to go off track again quickly. If you look closely at that one, that's standing seam. So not only can you use standing seam on the roof, but you can use standing seam on the walls, and it looks awesome. Now, if you look even closer, you can see that it's shingled. And how we did that is we took 4-foot lengths of standing seam, created a joggle cleat, so they hook like this, and then ran battens along the entire length. So it looked like a continuous length panel, even though it's not. And looks fantastic. So standing seam can also be used on the walls. Again, that's concealed fastener, right? So intermixed profiles here. I mean, you can do flat that's on the right side. It's just anything under the sun. Okay, thermal movement. I've touched on this a little bit so far, but metal is a party animal, okay? Metal likes to dance, it likes to move, it likes to sing, it likes to just get around, right? Metal moves. For steel, general rule of thumb is 1/8 of an inch of movement over a 10-foot length of panel. Now, granted, if you're in the Pacific Northwest and you don't have large temperature variances and you're not seeing, you know, sun every day, it won't move that much. But if you're in the middle of the Mojave Desert or in Texas, where it's, you know, boots with the fur in the morning when you go to work with a cup of coffee, right? And when you come home and you're like stripping out down to your like undershirt or something, right? That type of movement, it'll move. Now, aluminum is even more of a party animal. It likes to move even more than steel. Steel's like, man, I can't party as hard as you, aluminum, right? So aluminum will move 1/4 of an inch over a 10-foot stick. So think of this in terms, I know this is walls, but think of this in terms of standing seam, right? If you're doing like an 80-foot run with steel, that's an inch of movement. So aluminum moves even more. So most concealed fastener assemblies will allow for this movement through clips that slide within their engagement, but through fastened panels have to absorb this movement in their corrugations, which I said act as little springs. So again, exposed fastener panels do not accommodate for this movement outside of their corrugation. So the hole may stretch or tear, resulting in leaks. I touched on that, oversized fastener, but they offer great, first of all, they're much less expensive, and they offer great implementation for a wide variety, but just keep in mind those differences between those two. Also, they're easier to replace. And what I mean by that is say that you do, like in this photo right here is a dorm, right? Some kid walks outside, breaks up with their significant other and kicks the wall. Well, all right, we want to fix that. It'll be easier to back some fasteners out, order a new piece, slide it up underneath, put some new butyl tape in there, run some fasteners through, done deal. Concealed fastener panels, not so easy. Fasteners, you may have to cut the panel open and disengage it. It may be a lot more work. So there's that aspect. And going off on a tangent one more time, if you're doing anything within the range of human interaction, i.e. first, maybe up to second floor, anything at a school where balls will hit it or skateboards will go down standing seam roofs or so on, up your gauge. The minimum gauge for a wall within human interaction should be 22, period. I don't care what anyone else says. 24 is even too thin. 22 gauge. Someone will walk out, kick it, a ball will hit it, they'll lean up against the wall to have a smoke or make a call or whatever, right? It will get interacted with. So just make sure that you keep that in mind. There's your labs, as I touched on previously. Sealant will always be in there. Well, I should say under IBC, you are allowed to go over an unconditioned space. There's no restriction, but over a conditioned space, it is 3 and 12, or it is 1 and 12 with exposed fastener panels and laps in the sealant or solder. So 1 and 12 is your on a standing seam on a excuse me on a roofing application, you're limited to 112, but in a wall application, no limitations. This is a concealed fastener panel. There's a whole bunch of different types of ways that you can interact, some with integral seams, some with not. But the factory sealant's typically in the female leg where it connects. This is a better example. This is what most of these are going to look like. Flush clip, standoff clip, direct fastened. Direct fasten won't allow for thermal movement. Flush or standoff clips will. The standoff clip functions the same as the flush clip, but elevates it off of the substrate. So the hook uses 2 reverse rolled hems that positively engage one another, as you can see. This allows for the unlimited thermal movement. Okay, so lap configurations, right? The hook seam panels generally have a substantially higher structural performance when used with clips. They offer better weather tightness as well due to their concealed attachment, and they've probably been attested and approved through ASTM E283 air and 331 water. The one-piece clips that are used with hook seam panels are often very simple in design and provide unlimited thermal movement because the panels can expand and contract within the clip. They're not binded. They can move, they can party, they can dance. So tried to get through that. I know we're short on time. So questions?
Okay, lots of questions here, Jeff.
I figured if
How
that
often should you check the fasteners for exposed fastened metal roofing?
Okay. Exposed fastened metal roofing. Roofing is exposed substantially more than walls. General rule of thumb, I would say, is in the first 2 to 5 years, you're going to be solid. After then, I would do it every 6 months at a minimum. Okay. Those fasteners have neoprene washers that are supposed to compress under a correct torsion. So if they overdrive that fastener, it will overcompress that washer and it will tend to leak and crack. Or if they underdrive it, it won't seat properly. So it's key to make sure that they have the torque setting. So it will drive that fastener the exact same every time. But I would say, as a general rule of thumb, first 1 to 3, 1 to 5 at the outside, you're going to be solid. After that, every 6 months.
Do the climate considerations you mentioned earlier affect only single skin metal, or do they apply to all metal panels?
Okay. Nuanced question. Let me preface this by stating this is a single skin presentation, which means there's no insulation behind that panel, okay? If you're going the IMP route, the insulated metal panel route, there's a lot of other considerations that come in. IMPs are generally aluminum in nature, and they require an aluminum substrate or similar or wood to attach to because of the dissimilar metals issue. With the insulation that is used, which is, oh gosh, there's a huge lawsuit in the 70s and 80s over it. Oh my God, I just went blank again. Anyway, they're generally aluminum due to that. But I can't really give you an answer on that one because that's the IMP side of things. Hope that helps.
Okay, let's do one more. Are fluid applied vapor barriers acceptable in place of underlayment?
So on walls, this is a horrible thing to say, but I don't know another way to say it. There's 100 ways to skin a cat, right? Wall assemblies are very varied. Typically speaking, you can use like the Tyvek underlayment. There's different perm ratings, type 1, type 2, type 3, whatever your building occupancy is, you're going to have a different wall. If you have, if you're doing an indoor water slide park like a Great Wolf Lodge versus, a concert hall or a museum where you have to keep everything nice and dry on the inside, but you have a lot of people coming in and occupancy. So my answer to that is building specific, project specific, occupancy specific, location specific, but yes, they are commonly used in lieu of like a type 2.
Okay, let's get back to your presentation and we'll take a couple more questions at the end.
Okay. So horizontal versus vertical. I'm going to go on a tangent again here. If you're doing any furring, you want to make sure that it is always perpendicular to your panel orientation. Okay, perpendicular. All right. So they can go vertical or horizontal. Vertical applications offer a lot of flexibility because you can install left to right or right to left. And you can do floor breaks or non-floor breaks. Like there's tall panels, you can do shorter panels in different lengths. Typically speaking, wall panels will go up to a length of about 40 feet. Anything over that, manufacturer may be specific, but generally speaking, it's 25 to 40 feet in maximum length for concealed fastener. Over that, it may get difficult to handle. So keep that in mind. That's generally speaking, the overwhelmingly large number of projects can hit that. When installing the seamed panels, they're intended to be installed from the top of an elevation down due to seam configuration. That probably makes sense for waterproofing, right? If they're the bottom up, the female leg can entrap the runoff, which will compromise the panel over time, okay? Not can, it says can there, it will not, it will. So make sure that you install those correctly. The traditional side lap seams, hook and seams are just the opposite. The traditional side lap are required to be installed from the bottom of an elevation up, which allow the runoff to flow over the lap. Installing from the top down can compromise weather tightness over time due to the exposed seams. But it's very important to take these into consideration when selecting the appropriate product for the application and phasing of the installation. This is the wall version of how to correctly shingle. Okay, there was a question earlier, can it be installed directly to substrate? Yes, doesn't matter what it is. So in this photo here, you're seeing that standing seam shingled application that I was speaking about earlier with the joggle cleats where they interlock like this, and then a batten is run down the entire length. This is being installed over block. It was shimmed out so that it would all be plumbed and level. But yes, you can install over a variety of substrates from anything listed. Fasteners. So the rule of thumb here is contact your manufacturer for their fasteners. Don't go off on your own tangent here, okay? Use manufacturer's suggested fasteners for the substrate type and thickness. Now, there's an issue where you can specify in too far. And as a designer, you don't want liability. It is my job to take liability off of you, right? So if you don't specify enough, you specify at the 40,000 foot level, put up a white panel. Man, you can get anything under the sun, right? I mean, put it in terms of a car. If you're going to public bid that, I want a white car. Okay, well, is it, a bottom of the line, 1980 used Honda? Or are you talking about a, brand new Lexus or something, right? If you don't specify enough, it's wide open. You're not going to get what you want. If you specify it in too far, you take on liability, okay? If you specify the wrong fastener, if you detail something that is really a site condition and you have measurements and you're off, that extra measurement is on you. So you don't want to specify too high. You don't want to specify too specific. You want to hit that middle. Nice, I have zero liability. You figure it out. And if you don't figure it out, it's on you, okay? So easiest way to do that, use manufacturer's suggested clips, fasteners, manufacturer standard details for this condition, and put it on the sub. What I can say is don't have them obtain fasteners from a supply store, like I said earlier, with the trim and the flat stock that can have different paint systems and so on. You want to make sure you get fasteners from the manufacturer. Pay the extra $10 for a bag. Like, seriously, it's not going to break the bank, and they're going to be appropriate. Okay. Reports. IATMO, ICC, Intertech are the same, right? These are the paid certification bodies who develops evaluation criteria. They have a document which defines the requirements for the conditions you have to meet. Then the manufacturer seeking the approval report goes in, submits, and they independent test data, performance calcs, and so on. The certification body takes it and then puts it into a report. IATMO, ICC, same thing. Kleenex, tissue, right? Same thing, accepted. IATMO, which I can say is currently the only known certification body that has an evaluation criteria for their metal siding. ICC has done a good job on roofing and so on, but IATMO is for your metal siding. So keep in mind, when you're doing a wall, it is not us that you need to worry about. Metal siding, metal roof are all prescriptively defined within the building codes and do not require a product approval report. They are defined as non-combustible, right? Manufacturers do have approval reports to make them significantly easier to work with, like the ICCC or IATMO, accreditation bodies. But metal, it's the assembly. So if you're asking for a wall assembly, you're going to have to reach out to the manufacturer of the components within the wall to get that fire rated assembly, because it's going to say this product with single skin metal siding. Well, that's all of us. Okay, that's everything that most manufacturers make is all single skin metal siding. So reach out to the other manufacturers for wall assemblies. What I can tell you is for roofing assemblies, they're so much more condensed and not as copious, numerous, that most manufacturers have their own evaluation reports over like different substrates, metal, ISO, coverboard, wood, combustible decks, ISO or no ISO, coverboard, no coverboard, metal panel. That's the extent of it, right? So anyway, I'm going to skip through this. So I can walk you through how to read this real quick. I know it's a pain to see, but if you look at the substrate right here, pick your substrate. Let's pick steel right there. The thickness, let's do 18 gauge. Everything is now limited to this line. Okay. Fastener size, boom. Attachment pattern, there's your loading. You take your site-specific building wind calcs, okay, which takes into consideration all kinds of factors from eave height to location, occupancy, all that. You get a number of loading that you need. You then can extrapolate this out. So you need, let's use 50, okay? And we're going to use LRFD because that's what you're using most of the time. Steel, 18 gauge. This is your line. LRFD, you're in gray. You need 50. Okay, well, you can do 2 foot on center. It's 190. Okay, you can do 2'6" on center. It's 152. Let's push it out. 54, 7 foot on center. Okay, cool. That's still above your 50. But if you move out to 8 foot on center, it's 47. No longer applies. Can't use it. Your max spacing is therefore defined on these charts. You can go closer. It'll just increase your performance. The max spacing. That's my rundown on that real quick. One more thing. Tangent again. UL is not the same as an ASTM test, okay? UL is a pass-fail. ASTM is a push to failure, okay? Imagine you're going in for surgery. Do you want the surgeon who has the UL certification to pass-fail? Oh, yeah, I got 70.5%. I'll cut you open. Or do you want the surgeon that was ranked top of their class, okay? And they're like, I'm, number 1. Here's where my ranking is. That's ASTM versus UL. So keep that in mind. ASTM, push to failure. That's where all these loads come from. UL, pass fail. Okay, I have a lot to get through. Underlayment, drawing the building. This is going to be building specific. I spoke on this, the perm ratings of class 1, 2s, and 3s. Contact me for that. Under rating system, I'm going to skip this. Okay, we're going to go through details real quick. What I want you to pay attention to here is note that there's a 1/4" gap between the base flashing and the bottom of the panel to allow for weepage of any backside moisture condensation and expansion down, okay? You should also always avoid direct contact with mortar and concrete. It should not be used around or concrete or mortar. Concrete and mortar are highly alkaline, and bare aluminum, zinc, and painted sheets will suffer rapid corrosion when in contact with mortar and concrete. What's this one? Oh, the photo with the gray siding shows what a cut panel edge termed into a J-trim looks like. J-trim, don't do it. Okay, it'll trap moisture and act as a gutter along the bottom of that panel. This will lead to premature panel deterioration. Siding trim that is sloped away from the building is absolutely critical. Okay, parapet detail. You've seen this before. We're going to go through these details because I have 3 minutes to cover like 12 slides. Inside and outside corner details. These are your typical that you're going to see. Again, this is all going to be product specific. Trim pieces, though, on these are typically used to attach to the high ribs of the panel with blind rivets at 12 inches on center to minimize the appearance of the exposed fasteners here. Profiled closures are installed between the panel corner trim to prevent wind-driven particulate, bugs, pests, nests being built by birds, making for a weather-resistive seal at the corners. These will follow the panel profiles. Let me see here. Inside and outside corner conditions will give you a vertical line break in the profile. The size of the corner trim can be adjusted. It doesn't have to be this wide. It can be thinner or wider, but what you want to do is bury those foam closures, those neoprene closures. So the typical size in this is a 4x4 to a 6x6 range. It can be adjusted. Another option for inside and outside corners is what is known as a profiled or a mitered corner. This option gives the appearance of the panel cleanly transitioning. This method is typically only used on horizontal applications because it's near impossible on vertical, right? But as you can see, there's fasteners that run down, but that corner is nice and clean. There's a lot of companies that can do this out there. If you're interested, send me an email, because I don't think I can say trade names on this presentation. This is your window or louver head condition. A header trim is installed prior to whatever might be installed at this condition. Header trim first. This allows for the proper seal between the header flashing and the opening frame. Just like a base detail, the 1/4" gap is there to allow for weepage and so on. Jam condition, boring. Move on. Sill condition, talked about that already. Soffit transition, these are cool. Okay, so this is a unique condition that would be a siding panel or a fascia panel to a soffit transition. It's handled the same as a typical base condition with one exception. The cover trim is an adaptation of the base trim flashing with the extra long return to allow for an overlap onto the desired soffit material. Once again, cover trim is an adaptation of the base trim flashing. So it allows for an overlap onto the desired soffit material, okay? Easy enough. Sequencing is key here. So it would be soffit first, then cover trim, then siding fascia, right? Okay. Penetrations. Don't mess with these unless you have to. This is specifying in too far. Your sheet metal sub, they're paid as much as a heart surgeon for a reason, okay? Let them do their work. These conditions can vary widely from a hose bib to a saddle, all kinds of different things. These can be achieved by all kinds of custom fab work. If you want to detail something, go ahead, but beware of the diving in too far. I would let the sheet metal sub do what they do best. Most siding penetration mounts need to be field fabbed after panels are installed to ensure proper placement because it's near impossible to measure otherwise. Rib layouts on exposed fasteners can affect the size of the mounting plate that's required. Okay, end laps for nestable products are fairly simple to achieve. The panel will just lap over one another. This is known as nesting, like I said earlier, nesting. They are exposed fastener profiles. Concealed fastener panels don't nest, right? These laps are between 3 to 6 inches and are sealed within the lap of 2 beads of gunnable non-skinning butyl. Nestable overlaps gives a clean and straight lap line and exposed fastener profiles only. Almost done. Thanks for staying with me. Concealed fastener version, unlike the nestable profiles, the non-nestable profiles require through fastened trim pieces to achieve the panel end laps. Again, non-nestable, concealed fastener require through fastened trim pieces to achieve the panel end laps. This may work or it may not, but it works with both horizontal and vertical applications, horizontal and vertical orientations. The vertical trim lap line shown with the horizontal panel in this photo. Am I moving fast enough? Okay, butt splice. Butt splice with a splice plate installed behind the panel would be used on an application where different size and color profiles are going to be located on the same elevation or where the project won't allow for splice trim to be used. 2 more slides. Ready? Splice laps are shown here because this is an awesome photo of the different colors there. Color mix project and also used on a long siding room. Careful consideration should be taken when selecting this kind of lap, as you will notice the panel end variations and the male lap lines are visible. So, but it still looks cool, right? We made it. This is it. Oh, one more. Vertical panel orientations with the horizontal trim lap can give you a unique appearance as well. Floor breaks, etc. This is the mixed and match profiles I was talking about earlier within the same concealed fastener. You can see the different profiles all mixed and matched. There's the end. Okay. All right. Questions? I'm ready to go for however long we need.
Let's do one last question, Jeff.
Okay.
If a panel in the middle of a wall or surface were damaged by hail or otherwise, how do you replace a panel without removing the entire surface?
Okay. This is applicable for both standing seam and wall panels. It is going to depend on the product utilized. If it is a through fastened panel, you back out the fasteners, take that panel section out, replace it, run the through fasteners back through, problem solved. If it is on a concealed fastener profile, it depends if it's directional or non-directional. What I mean by that is do install from left to right, top to bottom, etc. Generally speaking, wall panels will be directional because they have a male-female leg. You will have to pull off all of the panels to that point to repair or replace that panel. The exception to this is on roofing systems that use a batten-style means of securement. Your batten-style panels, your bulb seams, your T-seams. You can cut the batten or remove the batten and pull that one panel out, replace the one panel. and put a batten seam back on top. If you have a very skilled metal sub, they may be able to finagle a concealed fastened panel out, depending on the connection, or removing a limited amount of panels around it. But yes, generally speaking, everything will have to come off to replace that panel.
Okay, thank you, Jeff. I'm afraid that's all the time we have for today. If you need to reach out with any additional questions, Jeff's contact information is currently up on the screen. Just a reminder before everyone leaves, if you would like to re-watch today's presentation or share it with a colleague, we'll be emailing the link to the recording to everyone who registered for the webinar within a week. Once again, it may take up to 5 business days if you are requiring a certificate, so keep an eye out on your inbox and don't forget to check your spam or junk folder. Finally, after you shut down Zoom, you'll be taken to a survey to provide feedback on your experience today. Please take a moment to complete the survey as it helps us to continue to serve your needs in the future. Thanks again, Jeff. Thanks for everyone for joining us. Have a great day.
Thanks, guys.